In your earlier studies of kinematics, you learned how to describe motion using displacement, velocity, and acceleration. But kinematics never asks why things move. Dynamics is the why. At the heart of this unit is mass, acting as a measure of inertia, an object's natural resistance to any change in its state of motion. To overcome this inertia and accelerate an object, you need a resultant force governed by Newton's laws. By combining these laws with the concept of momentum, you will transition from simply describing the physical world to actively predicting its mechanical future.
We begin with the absolute foundation of classical mechanics, momentum and Newton's laws. You will learn to state all three of Newton's laws exactly as required by Cambridge examiners. You will discover that Newton's second law is fundamentally about the rate at which momentum changes, not just F equals ma. And you will learn to spot true action-reaction force pairs in any scenario, whether it is a hovering helicopter or a block sliding down a slope. Next, we look at linear momentum and its conservation. Momentum is simply the product of an object's mass and its velocity. Because velocity is a vector, momentum is a vector too. You will use the concept of impulse to understand how forces act over time. More importantly, you will conserve total momentum to predict the exact outcomes of high-speed collisions and complex explosions. Topic 3 is elastic and inelastic collisions. While total momentum is always conserved in a closed system, total kinetic energy is not. You will learn to classify perfectly elastic collisions based on whether total kinetic energy is perfectly conserved. You will track the energy before and after impact, and you will apply the relative speed rule to bypass pages of messy algebra in Paper 2.
Finally, we tackle force and acceleration. This is where you bring all your tools together to analyze complex mechanical systems. You will learn to draw precise force diagrams to ensure you never miss a hidden force like friction. You will resolve forces on inclines and calculate the acceleration of connected bodies. Whether a car is towing a trailer or an elevator is accelerating upwards, you will find the resultant force and unlock the entire situation. Dynamics is a highly interconnected unit, accounting for 10 to 15% of your total AS level marks. You cannot understand collisions without understanding momentum, and you cannot understand momentum without understanding Newton's laws. Master these concepts. Always define your positive directions carefully before writing equations, and you will have a complete, powerful toolkit for analyzing forces and motion. Let's get started.